So let's say if we have um a similar problem, if we have f, x, y, z, 1, 2, 6, and 7 in this case. Uh, so we want to design this logic function using 4 to 1 multiplexer with two selectors, S1 and S0. So in the previous example, it's easier because we have 8 to 1 multiplexer and we have three selectors, S2, S1, and S0. So now what will happen? What will happen if we try to implement a three variable Boolean function, but only using 4 to 1 multiplexer with two selectors? Okay, so basically the same procedures apply. We list the truth table and the first n minus 1 variables are connected to the selection inputs, and the remaining variable which is not connected to the selection inputs will be used as the data inputs. Okay, so how do we do that? Let's look. Okay, the truth table now looks something like this. It's the same as the previous one. Okay, we just list down, put the ones where it should be, at 1, 2, 6, and finally 7. Okay, so the difference now is that we are only using for 4 to 1 multiplexer, so there's only two selectors, so only x and y will be selected, will be the selectors. Z will become the input. If you look down here, when we want to implement the multiplexer, since z is not the selectors, so we put it as one of the, or rather two of the multiplexers input. Okay, so input I0, I1, I2, and I3. Input 0 is connected to Z. Okay, and input 1 is connected to Z bar, which is the inverse of Z. And input number 3, input 2, I2 is connected to 0, which is the ground. And finally, I3 is connected to 1. Okay, now the output F is determined by the selectors and the current condition of Z. Okay, if both X and Y, which are the selectors, are zeros, so F will become equals to Z. All right. And if both S1 and S2, S1 is 0, S2 is 1, F will become equals to Z bar, or the inverse of Z. And if both S1 and S2 are like this, so S1 is 1, S2 is 0, so F will become 0, the output will become 0. And finally, if both S1 and S2 are 1, F will become 1. Okay, so that's how the selection process works for this type of problem. When we want to implement three variables Boolean function, but only using 4 to 1 multiplexer. So it's a bit trickier than the previous one, since there's only two selectors. All right, but it's not that hard. So if we understand how it works. Okay, so F, the condition for F is either Z or Z inverse, 0 or 1, and it depends on the condition, the current condition of the selectors. Okay, and there's another problem example shown here, which is the now we have four variables A, B, C, D. So we will have 16 different combination of inputs. Okay, A, B, C, D, 4, so there's 16, and only output 1, 3, 4, 11, 12, 13, 14, 15 are high. Okay, so if you want to let's say we want to design this using an 8 to 1 multiplexer, with 3 selectors. So how does that looks like? Okay, so the procedures is still the same. List the truth table, evaluate the output as a function of the last variable 0 1, and the variable of the complements of the variable or the complement of the variable. Apply the first n minus 1 variables to the selection inputs, and the connect 0 1 the variable and the complement of the variable to the data input according to the result of step 2. It's just the same as the previous one, but this one with we have these three as selectors, and this one we put D we put as the data inputs. Okay, so it looks like this. Now what I want you to do is try to do this example on your own. Try to understand how it works, and try to do it on your own first. See that if you get the same result as the example shown in the notes here. Okay. Now this is another. This is how multiplexers are implemented in the form of the TTL IC. Okay. This one is for dual 4 input data selector or multiplexer, and this one is 8 input data selectors. And in Multisim, it looks like this. Okay, so this one is 2 4, this one is 8, and this one is 16. Okay, everyone, as an exercise, why don't you try on your own to solve this problem? Okay, design an 8 to 1 multiplexer that has 3 selectors. The output of the multiplexer will become high only when the inputs are only when inputs 1, 2, 4, and 6 are selected by the selector. Okay, and the procedure to solve this is the same as the previous one. List the truth table, find out which variables are connected to the selection or the selectors, and connect 0 and 1 to the data inputs or according to the truth table. Okay, try this one. And there's another one that you can try. Implement the following Boolean function with 8 to 1 multiplexer. Okay, this is similar to the example we've seen before. And there's another um, exercise that you can try. Let's say we have f a b c d like this, a function like this. So design the same logic function as in example 3, but this time using 16 to 1 multiplexer with 4 selectors. Okay, so it will be much simpler. Okay, that's it for multiplexer. I hope that you will learn something about multiplexer in this video. Hopefully you can design a multiplexer by the end of this video. Okay, next we're going to look at demultiplexer. Okay, see you in the next video.